So this is the 1.5 lesson, more on slope. There's two main topics we're going to talk about today, as you can see on the screen. We're going to start with finding slopes and equations of parallel and perpendicular lines. And then we're also going to talk about slope as a rate of change, which may be a little bit new, still the same concept about slope, but it might be less familiar than other things we've talked about so far. So two short concepts we're going to talk about in this lesson. This first page is a review on parallel and perpendicular lines and what we know about their slopes. So first thing is talking about parallel lines. We know the slopes of parallel lines are equal. Okay, so if we have parallel lines like this, parallel lines have the same slope. You've talked about it in Algebra 1, Algebra 2, and even in geometry, you talked about parallel lines having the same slope. So probably pretty familiar. The next thing is the slopes of perpendicular lines are negative reciprocals of each other. This also means that the product of the slopes is -1. So here we've got perpendicular lines. I can draw you an example. Perpendicular lines intersect at a 90-degree angle. So there we've got perpendicular lines. Negative reciprocals, a review about what this means is we could have, let's say, the slope of line A is 8, and then the slope of line B is -1/8. So negative means the signs are going to be different. One's positive, one's negative. Reciprocal is we flip that number. So the first number is 8. If we flip that 8/1, we're going to flip it. It's going to become 1/8. You can always check to make sure two numbers are negative reciprocals by multiplying them together. If you multiply them together, we should get -1. So 8 times -1/8 is going to be -1. I know for sure they're negative reciprocals. Another example I can show you, let's say if the slope of line C is -1/9, then the slope of line D, if it's perpendicular, will be 9. And we can double check that. -1/9 times 9 is going to be -1. I know for sure they're perpendicular. They have negative reciprocal slopes. So let's just check out an example, two examples working with parallel and perpendicular lines. So this first one, it says write the equation of the line described. So we have a line parallel to y equals 6x minus 2 through the point 1, -3. So as soon as we know it's parallel, we have parallel lines, we're going to pull out the slope. And we know the slope is the m value, that's going to be 6. These two lines are parallel, so they're both going to have the slope of 6. And it goes through this point, 1, -3. We're going to write the equation of this new line. And in order to write the equation of this new line, I am going to use point slope form. And we talked about this morning. I'm going to use it again. There's point slope form. So let's substitute in, we've got a point, we've got a slope, point slope form. So let's do y minus -3 equals my slope of 6 times x minus my x1 is -3. Oh, sorry, my x is 1. Let me back up there. X was 1. And now we'll simplify this. Let's do y minus a -3. So I'm going to have y plus 3. And we'll distribute the 6. So I'll have 6x minus 6. Be careful with your signs there when you distribute. And then we're going to subtract this 3 on both sides. When we subtract the 3 on both sides to get the y by itself, we're going to end up with y equals 6x minus 9. And there's the equation of the line that's parallel to this line right here. Notice they've got the same slopes. And then the second problem is very similar. We're going to do very similar steps, but now we are writing the equation of a line that's perpendicular to the line y equals -4x plus 2/3 that goes through the point 8, 5. So as soon as it says perpendicular, I'm going to look for my slope and find the negative reciprocal or opposite reciprocal of the slope. So -4, I know my perpendicular slope is going to be a positive, change opposite signs. And then 4, the reciprocal of 4 is 1/4. And we're going to do those same steps using that same point slope form. So I'm going to do y minus my y1, which is 5. equals my slope, which is 1/4, times x minus x1, which is 8. And then let's do some simplifying. We'll have y minus 5. Distribute this 1/4. So I'll have 1/4 x. Distribute it to -8 on the side here. I'll show you 1/4 times -8. Multiply fractions. We go straight across, or we can reduce them first before we go straight across. I know 4 goes into 8 2 times, and now when I go straight across, I end up with -2. And then we'll solve for y to write the equation of the line. I'll add 5 to both sides. So my perpendicular line equation is 1/4 x plus 3. Is that all right? 1/4 x 8 2 plus 3. Yes. Any questions for me? Let me know in the chat. And that's just some review on finding equations of parallel and perpendicular lines. The next thing we're going to talk about is average rate of change. Give you a second to copy anything else down. Okay, so average rate of change, we have a definition up here for you. Average rate of change should be a familiar description for slope, because this is the same exact thing as slope. We still use the same formula. But the main difference here when we talk about average rate of change is it doesn't need to be on a line. So notice it says average rate of change of a function. And so I'm going to write in here, not necessarily a line. Notice in the description below that we're talking about f of x. It's a function. We know f of x. So right here, x1 comma f of x1, we know f of x is the same thing as y. So we're just using different variables. We're using function notation, but we do know f of x is the same thing as y. And so here's that same exact slope formula, but notice now we're going to use function notation. F of x2 minus f of x1 over x2 minus x1 instead of y2, y1. And so why we're going to talk about average rate of change of a function is because we can still find the slope between 2 points that are on a function, not necessarily a line. For example, if I have a quadratic function here that's graphed, I can still find the slope of this point and this point. And so we're going to do this in the problem right below this on the last page here. I can still find the slope of 2 points that are on a function that are on, they create that line, but they are not on a line to start. They're on the function. They're on a quadratic graph to start. And so what these types of problems look like, for an example, here's example 2. It says find the average rate of change of f of x equals x squared from x1 equals 0 to x2 equals 1. So notice they give you x values. And so average rate of change is still slope. I still need to find the y values. I still need points. And so what we're going to do is I kind of like to set up points. I have 0 comma something. I don't know what the y is. And then 1 comma something. I don't know what the y is, right? Notice these are 2 x values for 2 different points. We know how to find the y values when we're given a function. So I'm going to find f of 0, and it's 0 squared, so that's going to give me 0. Here's the y value for this point. And then I'll substitute in 1, and I'll find f of 1 equals 1 squared, which I know is 1. And so now I can find the average of change, the slope of these 2 points from one x value to the next x value. So we will write it just like normal. I'm going to have average rate of change. We'll have 1 minus 0 over 1 minus 0. So I'm going to get 1 over 1, which means the average rate of change is 1. The slope is 1 from x1 equals 0 to x2 equals 1. So let's talk about that slope. It's at this positive, right? It's slowly increasing. And that's important because I want to show you then compare it to the slope of b here. So let's try this again. We want to find the average rate of change of f of x equals x squared from x1 equals -2 to x2 equals 0. So I've got 2 points here, -2 comma something, I don't know yet, and then 0 comma, well, I already know that's going to be 0. So if I substitute in -2, I'm going to get the y value of 4. And so now let's find the slope of these 2 points. So I'm going to go and find the average rate of change, and I'm going to do 0 minus 4 over 0 minus -2. 0 minus 4 is going to give me -4 over 0 minus -2 is going to give me 2. Simplify that, and I get a slope or an average rate of change of -2 from the x values of -2 to 0. And I just want to compare these two slopes, and then we're all done this lesson. Let's just think about, because we can all be able to visualize this graph, right? That's a parent function. F of x equals x squared. We have a quadratic function, a parabola centered at 0, 0, the origin. Think about these x values right here, 0 and 1. So and we can plot these points, 0, 0, and 1, 1. So think about this slope. That makes sense that the slope of the line that would go through those 2 points is 1. Okay? Those 2 points are on the parabola at 0, 0, and 1, 1. It makes sense, and you can visualize that that has a positive slope of 1. And then let's just compare it to these points here. -2 comma 4 would be, let's say, over here. And the origin we know is here. Again, now, if I draw a line through those 2 points, that makes perfect sense that the slope between those 2 points is -2. Okay, so average rate of change, same thing as slope, but we're just finding the slope between 2 points on a function, not necessarily a line. Okay, so this is your short lesson on section 1.5. If you have any questions, send them my way. Thanks for watching, guys.